Hey, everybody, and welcome to another React Wednesdays. I am TJ Van Tol. I work as a developer advocate at Blues Wireless. With me, Dan Wilson. How you doing?
Doing good. I also work at Blues Wireless where I head up marketing.
Fun stuff. Well, if you are joining us for the first time, React Wednesdays is a show. We do this every Wednesday, as the name sort of implies. Same time. We bring in cool people from around the React, from around the JavaScript world, just people doing interesting, fun things. We have them come on. We have them teach us something, show us something new, something exciting. I am going to drop a link to the website in the chat. If you're ever curious what shows are upcoming, who our guests are, some background, you can find that out there. You can add invites to your calendar, that sort of stuff. We have Solid.js coming up next week, which is a framework that I keep hearing about but don't really understand. So I'm excited to hear more about that. And we have the library's author coming on. So that should be pretty fun. So if you want to join that, head to the site, add that to your calendar, keep track of what's coming up. But for today, we're going to be talking audio apps, which is another thing that I don't understand as well as I would like to. And to help us, I'm going to bring on our guest for today, Nick Thompson. Nick, how's it going?
Great. Happy to be here.
Well, Nick, why don't you start by just telling us who you are, what you do, how you got into audio, all these types of things.
Sure. Yeah. Big question, I guess. But I am a freelance independent contractor in the audio software space. I run my own audio plugin company called Creative Intent, which has been around for a few years now. And I am also working on this project that we're going to talk about today, Elementary, which is a new framework really for working in audio from JavaScript. I got into this space from kind of a long history in electronic music production.
Fun.
At a certain point, kind of music writing hobby met, software development profession, and I tried to make it happen.
It's very fun. Dan might have some questions. I know he's into that's his musical taste of choice as well.
Yeah, I just looked up
Dan
your
came prepared.
VSPs, and I think I might have to go shopping. So thank you.
Let me know if you do.
Well, speaking of just audio and technology, I think so. I could say that I've never really touched this space at all. I'm totally unfamiliar with it, and part of it is that it's always been fairly overwhelming. Like I know, like the browser has an audio API, but that's just for like playing an MP3 sort of thing, right? And starting and stopping it, but I've always been very intimidated by just the raw audio software. It's always seemed really hard, really complex. So I'm curious, like your progression through that, how you started, and I'm very curious how JavaScript worked its way into this equation, because I never really thought of JavaScript as a language for dealing with these sort of things. So I'm sort of fascinated how it works its way into this story.
Yeah, great question. I mean, I guess it starts. Like for me, it started a long time ago, maybe 2013-ish, because my career started in web app development. So most of kind of the mid 2010s, I was working as a front-end web developer at a couple of different companies. A lot of time in React, some time in React Native, and some back-end server stuff sprinkled in there. But kind of the as I was getting into that field, I was doing almost everything in JavaScript. And especially when I found and started working with React, I was kind of hooked. I mean, just I had written a bunch of web apps before I found React, and the kind of paradigm shift that it encouraged for me was a game changer. And so this kind of started there. And then the web audio API showed up, which is in browser. You can do a lot more than just play audio files. And I think I found this in like 2013-ish. I forget exactly when it started showing up on the scene. And that was kind of this point in time where I was like, oh, so I can interact with audio from JavaScript. This opens a whole new world for me. And I did a lot of stuff with the web audio API, mostly personal hack projects. And once that kind of cracked the door open, I found myself thinking, why not just like try my hand at like really getting into this space and trying to write audio plugins, which you use all the time if you're a music producer. And that one took me a couple years to figure out. It wasn't until I found the C++ library called Juice that basically gave me enough of a push to get into the space. So anyways, I'm probably rambling, but arrived in the audio plugin space after that. And once I got there, I was really missing JavaScript, basically, and missing the developer experience of front-end web tools. So I was kind of looking for a while for how I could bring that experience back into the audio space.
Yeah, I know how you run unit tests against, say, a button on a website, but I don't know how you run unit tests on a VST. And maybe you should talk through that at some point when it becomes appropriate.
Yeah. It's tricky. I mean, unit tests in audio, it's kind of a tough thing to do. And the reason it's a tough thing to do is because, like, at the end of the day, the output of your function is, you know, a waveform, right? Like PCM waveform data. And so I've seen some unit testing systems which will basically like construct an audio processing graph, render some waveform data, some PCM data into a buffer, and then like check that against a known fixed buffer that maybe you're like keeping in your repository as a WAV file or something. But
if I was to read through some of the marketing materials on your website, I would see things like subtle randomness.
Yeah,
just got to really make the unit testing easy.
Exactly. I mean, even if you don't have subtle randomness, you have a ton of floating point number comparisons. You have, you know, like catching phase correctly is a little bit difficult. I mean, you have to basically make your audio processing pipeline perfectly deterministic to even begin this idea of doing unit tests this way, which kind of takes some of the fun out of the way that I like to interact with audio. And so when I do unit tests, I try to avoid going all the way down to like, you know, rendered audio data. And if I can, I deal more at kind of like the abstract graph layer to ensure that the graph I think I'm rendering is the one that, you know, the unit test thinks I'm rendering.
And then it seems like in the C++ environment, you've got very, very low level access to data and streams and binary and whatnot. Like rolling this back up to the JavaScript space, like where are the differences and what access as a JavaScript developer do I have with audio and what are sort of the boundaries I have to live in?
Yeah, well, it depends on what environment you're working in. I mean, if you're working in the browser with the Web Audio API, for example, most of what you do is kind of like graph topology construction, right? Like you can create a generator node and a filter node and string them together and then run them to your output sink. And that's kind of like the level that you work at. You don't have a lot of access to the underlying stuff. But the other thing that the Web Audio API introduced in the early days was the script processor node, which was basically like a JavaScript function that you could run in the audio process callback, which is kind of insane because the audio process callback has to be like perfectly on time, and running JavaScript in there on a high priority thread is risky business. So then came along like the Web Audio Worklet. I mean, I haven't actually worked in this space in a little bit, but they're working on ways to basically like give you access to some underlying buffers, some underlying data, and that kind of comes through as a float32 array in JavaScript land. But still, you have to be careful. I mean, garbage collection in the real-time thread is just a can of worms, and so I'm kind of weary of that approach, basically.
Yeah, given that, I wonder if it makes sense to kind of switch over and look at some code here and get oriented in what we're talking about.
Yeah, happy to. Okay, so what I want to show first is basically like the hello world of working with this runtime elementary. So I don't know how much of an intro I gave to elementary itself, but basically this project is a lot like Node.js in that there's this command line binary that hosts this JavaScript runtime that speaks audio, basically. And at the same time, it is a framework for like declaring in a very React way what you want your audio process to look like. So here's kind of the hello world, and this is exactly the one that I have in my examples repository on GitHub. So a lot of comments here, but what you need to, like, the interesting bit is all down here, right? So generally, when you run a elementary file with the command line tool, the first thing the command line tool is going to try to do is get your audio driver up and running. And so you can execute JavaScript before that point in time, but it's a lot like a browser. Like you often should wait for the load event to do any real work. And in this case, the load event is the point in time when elementary has your driver up and running, and we're ready to start dealing in, real-time audio buffers. And then there's this method down here, core.render, which is very much like the idea of rendering in React. And what you pass to it is a declarative composition of your signal chain. And so here I'm using some features from the core library, which I'm importing at the top. And you'll notice these are two different arguments to the render function. And these actually specify kind of like the entry point for the left and the right channel. So in the left channel, we're multiplying 0.3 by cycle at 440, which is a sine tone generator running at 440 hertz. In the right channel, 0.3 times a cycle running at 441. So this is the hello world. And if I close this and run it at the command line, you should be hearing a sine tone. Did that come through?
It
It's
did,
got a
yeah.
little
Okay.
wobble sound to it.
Yeah, the wobble sound is part of the demo, and what that comes from is the fact that I've offset the frequency that the sine tone runs at in the left channel and the right channel. So if I turn this to dead even 440 on each side, wobble's gone, right?
Static tone, yeah.
Yeah. And if I put that back, what's actually happening is this is binaural beating. Basically, like if you play two sine tones just offset from one another, then there's this periodic frequency at which they'll kind of like sum together and be a little louder, or just perfectly offset their phase from one another and cancel each other out. And if you do this in different channels, your brain kind of like tries to sum them together. They're perfectly discrete things. One goes in your right ear independently and has no beating. The other goes in your left ear, has no beating. But your brain sums them together and gives you that kind of wobble. It's an awesome. The first time I figured that out, I was psyched about it.
So I'm curious, what is the fascinating part to me is what's going on under the hood here. So
Totally.
is elementary, are you building on top of like C++ libraries? Are you somehow like getting access to like native drivers for working this? I'm curious like what the underlying tech stack looks like here.
Yeah, so most of this project is a C++ project, and most of the work here goes into basically getting this system set up that can, in real time, render this structure that you've asked it to and hand that over to the audio driver for your computer. And so JavaScript is really just in the same way that the web audio API, you do like graph topology construction. It's very similar to what's going on here, right? I'm declaring what I want my audio process to look like, and then basically on the C++ side, we take that declaration and make it happen in such a way that I can start rendering real-time audio to the driver. So I'd say like 90% of this project is C++.
Gotcha. And I imagine then there's some way that you expose, like the tricky part has got to be the communication, like the bridge, right? Like how JavaScript talks to C++. Is there like a common library or some sort of approach you're using to do the actual, because like if I were doing this today, that's the part that I would have absolutely no clue where to go, like the actual interface itself. So is there something like built into Node for this? Is there like a library that helps you do this, or
just magic?
Yeah. Magic. No, basically I'm using like a two-way pipe. It's a lot like the event emitter in Node, right? Except that I have kind of this, in fact, it's right here on elementary.core. You can write something like, I'm not going to run it because I don't remember if I broke this recently. But you can do something that looks like this, dispatch event, and then you can pass whatever you want here. And this will, like through this bridge, basically, the name and the event object, whatever it is, will propagate over to C++. And I have the same mechanism for coming back. So core.onload, when this fires, this goes through that same pipe. And it's actually the native side pushing the events into the queue to say, I have the drivers up and running.
This reminds me a ton of React Native's approach, because it's like an event bus. You just like, you have a listener on one end that's just like waiting for commands, and then like basically dispatch, it sounds like in this case, has to like synchronously just wait for C++ to do its thing. But because it's C++, it's pretty instantaneous.
Yeah, exactly.
Okay.
And React Native was definitely an inspiration. I mean, I worked in React for many years. I did maybe like a year or two working pretty heavily in React Native. And that was before kind of I switched into the audio domain. So very much, I think, the experience that I had with those tools and what I learned working with those tools came through in the way that I approached this project.
Well, I think they help show that this sort of approach is totally viable as well, because, I mean, React Native has certainly been successful. Dan and I were involved with a project called NativeScript, which is somewhat similar thing, though, like used by real companies, build real things, right? Been used at plenty of scale to show like, this isn't just like a hack. This is something that like can be trusted for big, important production things, for serious stuff too.
Mm-hmm. Totally. So next example?
Yeah, let's do it.
All right, I'm going to...
Oh, I'm sorry. I meant to ask a question earlier, and you may have addressed this to some degree, but to those listening, like how much of this project is usable purely just doing JavaScript? Is all of it?
Oh.
Can I use all of it?
Yeah, I mean...
Do I need to start making .h files and going crazy, dereferencing pointers and all that?
No. That is... The goal is that you don't have to do that. So elementary is kind of structured in, I guess, layers. So the command line tool, as we're working with here, as we're demonstrating here, you know, I want this to feel a lot like working with Node. Like in Node, you have these like built-in libraries that are actually like backed in C++, right? Like, I don't know, the crypto module has some C++ OpenSSL stuff underneath the hood that takes place in C++. But as a JavaScript developer, you don't even need to really care about that or know that. You just have this nice clean API that you get to use and stay in JavaScript. And that's the experience that I want to enable when using this. But, you know, I'm sure that somebody will come along, find this command line tool, start building something, and then go, hey, I actually need this particular feature. You know, I need this particular process to happen on the buffers in real time, and I can't find a way to express this in JavaScript. And I think that's the goal. Basically, is that at that point you can take kind of the core runtime, which will be available as an embedded SDK, and at this point you can like pop that into your C++ project or whatever, you know, you can put in your Rust project or whatever you have. Define this kind of low-level operation that you need to define, and then use that from JavaScript. It's a lot like in React Native, you can write your own native view, right? And then you register it with React, and you can deal with it from JavaScript. So my hope is that most people can stay in JavaScript, never think about C++, never think about pointers. But if you find that you have that super proprietary thing that you just have to have in C++, you can grab the runtime SDK, extend it with what you need, and then go back to JavaScript land.
Nice, more than fair.
Yeah. All right, let's take a look at the next example. So these examples, by the way, are all what I have written on GitHub. This is GitHub/Nick-Thompson/elementary. And I point that out because I tried to, as I was writing these, put a lot of comments in there so that people who are new to audio but familiar with JavaScript maybe can read through this and piece together what's happening, you know, without much of an audio background.
And I just tossed that link in the chat if people want to check that out while we're chatting.
Thanks. Yeah. All right. So this is the second example. And actually, maybe I'll start with just running it. So this one is a really simple arpeggio. There's an arpeggio happening in the left ear and the right ear. Again, they're different, but your brain makes them sound cohesive. Super simple. And I wanted to be simple because we'll get to the more complicated stuff later. So I'm going to start down here at the bottom. We've got our load event. And once this callback fires, we start to put together the arpeggio. So the first thing is this el.train. Now this is, are either of you familiar with like modular synthesis hardware?
Not really, sort of, kind of.
Perfect. Well, I'll go step by step. So the train here is like this represents a signal, which is a pulse train. It's a signal that stays at 0 until some point in time where it jumps immediately to 1. Then it hangs out at 1 and jumps immediately back to 0. And it will do this as specified here, like at the rate specified here. So here we have 5 hertz. So 5 times a second, I'm going to go up to 1 and then come back down to 0. Now, that is important because I'm triggering an ADSR with that signal. So that means that 5 times a second, I'm going to engage this ADSR. So an ADSR is a signal that will ramp from 0 up to 1 over the period of time specified here, which is the attack time. A very short attack time means that I'm basically going to get to 1 really quickly. And so you could hear what we were listening to had this very kind of like, articulated, plucky kind of sound, right? That's because we get to our 1 value really quickly in amplitude. Then we decay to the sustained value, which is specified here, over this period of time. So we're going up really quickly, and then we're falling really quickly back down to a low value. And then there's a release, which kind of like hangs off after that for half a second over here. So over the following half a second, we're going to drop back down to 0 amplitude. So this is just like the kind of contour of the sound. This is what gives the kind of like plucky character to the to the noise that we're listening to. So the next bit is down here. In the left and the right channel, again, I start with this this multiply. So we're going to multiply the envelope, as I just described, by this notion of a voice. And the voice is basically what's generating the tones, right? And then the envelope is what's kind of multiplying in to give that its contour. So that happens in the left and the right channel. And then down here, again, I just pump them out left and right, and I adjust the amplitude a little bit so that it's not super loud. Make sense so far?
Yep.
At a high level, at least.
Okay.
Yeah.
So the thing that is left unexplained here is the voice, right? So I'll explain the voice, but the first thing I want to show is that this voice function is actually just a function I declared up here. And you'll see that it takes a single argument, which is a frequency value, right? So I could get rid of all of this stuff and just render that frequency value. So now we're back to sine tones. So if I save this and run this, you can hear how like it lost a little bit of its character, right? Like now we've just got these really basic tones with the contour and the frequency arpeggio. So what's actually happening, if I put this back, or what I have in the example, is some really basic FM synthesis. And FM synthesis is where you have the same kind of like tone generator, but the frequency that we're going to run it at is going to be modulated by another oscillator. And so we start here at a sine tone, and I'm going to run it by adding into the frequency that I'm given this guy right here. Tell me if I'm explaining this poorly.
I think I get it.
So this stuff right here is just another frequency generator running at the same frequency, and I'm just multiplying this so that we're going to sweep back and forth across. Suppose that this is running at 440 hertz. I'm going to sweep back and forth between maybe like 440 and 880 hertz really quickly, and modulating the frequency of the bass sine tone at this rate is what gives it that kind of character that takes it away from simple tones and gives you more harmonics, more amber, I guess. So putting that back. And it doesn't sound amazing, but this is like, you know, basic exploration of stuff that you could do with elementary.
Yeah, and like I said, that I get this at a high level, and I think because I don't totally understand all the different, like I don't have a background in audio, like some of the audio terms and what these are doing don't totally make sense to me, but the code does, which I think is a big deal, because I could even jump in here, like I know JavaScript, the APIs make sense to me, the constructs make sense to me. I could experiment in here and sort of figure things out. Whereas if you threw me into a C++ file, I would not know what to do. The APIs would not make sense to me, right? So it's just far more explorable, I guess, in this syntax.
You know, one of the things that might be getting washed over is that ADSR piece on line 42. Like if you were just going to make a couple of quick numeric changes and have something wildly different, that'd be the line to mess with, because you can do a lot with that.
Yeah.
In fact, why don't you just freelance it and change those numbers and make it, you know, a little more, I don't know, like change the attack so it's longer so they can hear the ramp up and the softness. And
yeah. Before I do that, TJ, I'm really glad that you said that, because exactly what you said is a huge goal of mine. I mean, all of my like DSP knowledge is self-taught, and I remember, like, you know, when I was first getting into this, cracking open the textbooks, and I could read the textbooks and kind of make sense of it at a sort of intuitive level, you know, like signals flowing with one another. But when I had to change and like write that as a bunch of for loops over, you know, float buffers, it's really hard to look at that code and map that back to this sort of intuitive picture that you had of it. Which means that if you want to step in there and just change some things, it's pretty difficult, I find, to like really explore in that space. And so very much a goal of mine here is to like enable this kind of intuitive look at DSP, which I'm personally really enjoying, because it's in my experience just so much faster to try something out, which is, I don't know, how this all started for me. So yeah, Dan, great idea. Let's go ahead and tweak the ADSR. So the first thing I'm going to do is slow the train down. So the reason I want to slow the train down is because I'm going to give this contour a long attack time. But if I give this a long attack time and then the next trigger comes in, you know, we're going to restart the envelope. And actually, why don't I just do that? So here we're gonna sweep in over the course of a second, but that's not really gonna work because, you know, what is it? 200 milliseconds after I start sweeping, the next train edge is gonna come through, which will say, hey, start that envelope over again. And so we'll be like, we won't even be at full volume before this kind of gets cut and taken over. And so I'm expecting with this, that we'll move to our release phase before we've even ever climbed to a very helpful volume, because the pulse train will fall midway through its cycle. You
know, for those who are working to understand these concepts, would pulse train and like a frame be considered analogous in terms of what we're talking about, like this sort of snapshot of?
Yeah. That's, I mean, I think that's actually an awesome analog, and I haven't thought of it before, so I appreciate that. All right, so let's just see what this sounds like. I'm expecting that it's gonna be very quiet because we're barely making it up to amplitude before we're turning off the voice again. Oh, it actually gets up there pretty fast. Great.
And see, TJ, the characteristic of that was less like insta on and more like wow, wow, wow. You see what I mean?
Yeah.
I know how to wow pretty well, like, but
let's boost this up again. This will be 5 seconds. And this is the other thing to know about the ADSR in the standard library, is that it's an exponential curve. So this is not going to linearly approach 1 over 5 seconds. It will kind of like sweep up towards 1 with an exponential curve. So this is 5 seconds. You can hear that's quieter, right?
Yeah, it's quieter and less punchy at first.
Yeah, yeah. So now let's slow the train down. Actually, I'll go even 1 second. And this time I'm going to, so let's see. Yeah, so we're approaching 1, but the gate is now running at 1 hertz, which means that every 500 milliseconds, we're gonna be halfway through our period. And halfway is where the pulse train drops back down to 0, which is, you could picture this a lot like pushing and releasing a key on your keyboard. I'm pushing it, and exactly 500 milliseconds later, I'm releasing it. And so if it takes some time to ramp up to full volume and I let go before it even gets there, you know, we're going to move on to the next phase of the contour of this. So I'm going to boost here the kind of like target, the target value that we want to approach, and I will increase the decay. So now we're going to sweep up. At 500 milliseconds, we're going to start sweeping down a little more gently.
You almost have like a stringed instrument sound because it goes up and then comes down a little bit.
Yeah, yeah, yeah. Okay, so this is a really slow train. Waiting.
Party people, it's 6 beats per minute. Get out your rave sticks.
So that, I mean, I think that's a really helpful exploration. And you can, I mean, you can keep going here if you want, but you guys tell me if that helps kind of explain how the contour here is involved.
Yeah, no, it helps a lot. I think like there's a certain, again, like the thing to me is you're doing exactly what I would do if I were handed this example. Like it's one thing to read about what this function does, but it's far easier for me to say like, let's set this to a wild value and just see what happens. Because that's totally how I would learn from something like this.
Which honestly is like, that is the process through which discovery is made, right? Like, I mean, it's so hard, again, to sit down at this huge for loop of like imperative operations and be like, well, let me just see what happens if I turn this number crazy, right? Because if you get one of those like intermediate values in your big C++ block wrong, you could blow up the gain of the whole system and like, you know, bust your earphones or like, you know, give yourself this nasty jolt in your ears. Because it's I find it just so much harder to map like this kind of intuitive, well, what if onto, you know, that kind of system, which again, I've really been enjoying with elementary.
You know, this reminds me of when I first learned HTML. Like I was literally learning HTML, and the example had like, I guess, a background color of 0000000, and I'm like, okay, that's black. Let me see what all the other colors are. And my mental model was that 0000001 would be like purple or something.
Yeah.
And I got to like 0000060, and I'm like, this doesn't do anything. And I thought it was just broken. I couldn't see difference in the numbers. And then they started putting E's and F's in there, and my brain just exploded. And I don't know if I've ever recovered.
Totally. I hope that people have exactly that experience in the audio domain with elementary. That would just like, I would feel complete if that happened.
So one question I have, and if this is like jumping ahead too much, let me know, but I'm curious about putting some like UI on top of this, because to me, like that ADSR function is fun to experiment with, but what I would totally want to do is put some knobs on each of them. So I could hear this. So I'm curious how connecting all that together tends to work, or what you tend to recommend for that.
Totally. Let's do it. So let me, I guess first I will answer your question. Then I will wrap up this example and move us on to the next example where I think we can actually play with what you're looking for.
Okay, whatever makes the most sense for you to logically cover. If you want to defer the question, that's totally cool if we get to it.
So I get this question a lot, right? Like, how do I put a UI on this? And there's kind of like the reality of how you can do it now, and then there's where this project is headed, which I'm pretty excited about. So where this project is now, elementary is based on Node.js, right? So what I'm running here is actually like running inside the Node.js environment, which means that I can put a UI in front of this in the same way that I can put a UI in front of any other Node.js application. So typically this is like serving a web app, right? But there's a bunch of libraries showing up in the Node world for trying to integrate like native desktop GUIs. I think there's one called Node GUI on NPM for doing exactly this. But generally, right, like you could, for example, serve a web page, open a WebSocket, and then from the web page, as you're turning knobs that you've drawn in React, send WebSocket messages over to the server. The server grabs them, manipulates the audio in real time, and passes that over on to elementary C++ side to make it happen. We've also, I had someone in my Discord channel already put together an example of how you can kind of merge elementary with Electron to make the front end that way.
Yeah.
Which super cool project. I'll try to find the link.
Yeah, that kind of sounds like the dream to me, at least the JavaScript developer's dream, because I imagine Electron could run this, like the Node and C++ stuff natively, right? So that you just basically have instant access to that layer.
Totally. So that kind of brings me to where the project is headed, which one of the things I'm working on, which is still basically in private development, but I hope to share soon. Everything that I'm showing here can be like upseated out of the command line tool and embedded wherever you want it to go. And so I'm writing my own audio plugins in elementary right now. And this will be available to the public, hopefully in the early fall. But for those of you who are music producers, we're talking about basically like open up Ableton Live or FL Studio or whatever you have, open up the elementary plugin, write some JavaScript, hit play in your DAW, and you're running your stuff in real time.
That's wild.
Yeah, it's super fun. And so the other piece of this is, because this is going to take a bit of a plugin shape or application shape, I'll be introducing basically an API for manipulating the visual display from JavaScript as well. So in the same JavaScript file, you can say, I want my DSP to look like this, and I want a slider here and a slider here. And when I turn that slider, I want this to change in the DSP. All in one file, all in one spot. You don't have to think about how to get state back and forth over C++, event dispatching queues, etc.
Oh, but that sounds so fun.
My goal again is to just like facilitate the ability to just like work on this in an explorative way. So it should be just as easy to, like mess with random numbers and see what happens as it should be to like throw a slider on, map that to values and start just going.
Is there some level of complexity that you think that sort of necessitates doing it in raw C++? Because obviously you are giving up some level of performance for dealing with this. Is there like, if you needed to go nuts, which again, since I don't have a background in this, I don't even know what the equivalent of that would be, but is there some like level of performance where JavaScript just can't handle it and you need to go native?
Yeah, sure. I have kind of like a philosophical answer to this and a practical answer to this. The practical answer is, of course, right? Like I can't foresee all of the different ways that people might want to use this, which is great. And so I guarantee somebody will come along and be like, I love this thing, I want to use it, but I need this particular thing to be ultra high performance. And this is again part of the goal of having the SDK available for people who need it. So you can, for example, take the SDK when it's ready, which is hopefully in just a few weeks here. But take the SDK, embed it into a plugin host yourself, put up whatever UI you want around it. Like you don't have to use kind of what I'm planning to build for UIs if you need to do something particularly special. And in the same way that you can kind of register custom processors with the runtime, you can also actually interact with the native, kind of the native side of the SDK directly. So for example, what I want to show next actually is a synthesizer which receives events from my Midi controller and plays sounds accordingly. And that's a cool example because like Midi events triggering JavaScript callbacks is very much in this performance question, right? Because to run a JavaScript callback, I'm sort of like forfeiting some of the high performance guarantees that I might have if I stay in native. For example, like if I take a Midi event coming in from the like DAW, like Ableton Live, that thing is very precisely timed. And if I stay in native, I can guarantee sample accuracy. I can say like at exactly this time, this is what should be taking effect in the audio. But if instead I take that kind of out of the queue and run something over in JavaScript land, that's going to happen on a different thread, and I lose my guarantees there, right? But for people who need this, there's a way to interact natively. So you could step up to exactly that point in time where you need sample accuracy for Midi events, and then perform your operations natively. So again, I'm trying to make this flexible. I want, on one hand, to enable people to make cool stuff without thinking about these questions, but kind of like, enable advanced user mode or something if you have particular requirements.
Yeah, it's like the classic programming paradigm of like, don't prematurely optimize, because I think like a lot of things, a lot of people think they're going to have performance problems when they really aren't. So like, why not try the easy route until you actually notice the problem, and then you can say, okay, well, what other options do I have here?
Totally. And that kind of gets to my philosophical answer to the question, which is I would say that in my experience, especially in audio software, there's a tendency maybe to make kind of like wild trade-offs for marginal performance gains. For example, like this Midi event handling thing that I'm talking about, for example, like the type of latency that I'm introducing here is on the order of a millisecond or two. I mean, it depends on how much work you want to do in your Midi event callback in JavaScript, but it's really small, like not something that you'll really notice if you're just playing a keyboard. And for me, I would take that trade-off every time if it meant that I'm saving, a week of development time because the API is just easier to work with and the problems to solve are just, easier problems. And so, I don't know. I think that I kind of want to encourage this trade-off of like save dev time, worry about performance later. And if you need to pull out the advanced toolkit and get the SDK, it's there for you.
Yeah, I like Fool Snable in chat, which hopefully I'm pronouncing that correct. I like how they phrased it. We only need to avoid horrible performance. Bad performance is usually good enough.
Love it.
Which is good.
I mean, totally agree, right? Like humans are not zero millisecond latency.
Think for yourself, Nick. Actually, so I usually run my Ableton stuff off of Windows, and by usually I mean always. And I didn't know there was such a thing as an ASIO driver, and I'm like, God, I am horrible at the keyboard. Like I couldn't get any notes out and any kind of timing whatsoever. And I looked into this, and it turns out Windows is literally horrible for latency.
Yeah.
And so you might even be somewhat close. And it turns out I was somewhat close. But what I actually got outputted in the DAW was really bad. And so when you're talking about how much latency this brings in, my head went straight there. But it seems like if you're down at the 1.2 millisecond range, it's probably just not even really detectable much, is it?
That's my feeling about it. But there are also people who come along and say a couple milliseconds of latency is unacceptable. And I also want to be able to support those people.
Give me quantization or give me death. That's what I always say.
I did have a question come in through chat. With a preemptive or non-real-time OS, I guess we can't have guarantees even in native.
Yeah, I mean, I guess that's true, but you know, I think at the OS level, like you can set thread priorities and thread pinning to basically say to the operating system, like, hey man, please don't touch this unless you really, really need to. So maybe it's not a guarantee, but on average, it's effectively a guarantee. But yeah, I mean, I think to that question, you probably have to pull out like a full real-time OS if you want like strict guarantees here. But again, like, you know, we're like an OS interrupt, we're talking on the order of latency that a human would not notice.
Yeah.
So that's kind of my threshold when I really think about this stuff.
Well, maybe we could get into the Midi example. You got me excited now. I'm kind of curious.
Let's do it.
We'll say that's the one nice thing about these audio things is like it makes for good presentations like this. Anything that like you can see or hear is really fun.
Yeah, totally. So let me start off by just running this one again. I have a console.log in here, which is what that hi statement is, and I'll show you in a second. Also, I have a keyboard right behind me. I'm gonna press some keys on the keyboard. This is sending MIDI events into elementary, and you'll see a JavaScript payload being printed out. I have another console.log in the MIDI event handler. I hope that was not too loud.
No, it's perfect.
That was good.
So
had a very organ-y feel.
Yeah. This one, let's dive in. I like this one a lot. So again, I'm jumping all the way to the bottom. You can see our high. This is just from the load event fired, and this is kind of the next piece here. Like once the runtime's up and ready to roll, I install another event handler, and this one's for Midi. And by default, what happens is like when elementary kicks on, it's going to survey your system, find any available Midi input, and just like register a listener on it. So you don't have to do much. Just like install this callback, and then if you don't want Midi events coming from one of your Midi controllers, you can just like throw a little if block in there.
And like presumably under the hood, C++ is talking to like the OS to get those input connections and figure all that out for you. Okay.
Yep. Okay, so let's move on to what we're doing when we get a Midi event. Actually, I actually want to start with, let me get rid of all this because there's a lot here that could be confusing. So instead of wet dry, I'm going to just render out and out. All right, so when we get a Midi event, we're going to update some notion of voice state. I'll show you what that is in a second. And then we're going to put together its output. And output is just mapping each of the voice state, like mapping the voice state through this idea of a synthesizer voice and then summing them up. And then I'm rendering that with core.render into both the left and the right channel. So this is a mono output. It's the same thing in the left and the right. And if we do this, it's just the sawtooth, like just a basic oscillator, because I took away all the filters and delays and stuff. So the reason I want to show you this is basically speak to what happens when you actually use core.render. Because you'll notice, right, like I haven't called core.render until a Midi event comes in. And the first Midi event comes in is the first time I call render. But the second Midi event that comes in, I just call render again. And this is very React, right? Like I have some new state, I describe the new look and feel of my application, I send it over to React, React makes it happen. And elementary does the same thing. You can describe, the sound that should be happening at time A, the sound that should be happening at time B. Elementary will look at one, look at the other, and then get you from A to B without you having to think about it. So let's talk about the voice state. So to start here, all we have is an array of voices. There's 4 here, which is, so this will be a 4-voice polyphonic synth, which means that I can push and hold up to 4 keys at a time, and this can render it. If I push a 5th, I'm going to steal the voice from somebody else. So I can only make 4 noises at a time, but you could make this an 8-voice polyphonic synth like that. Each voice will have a gate. This is a lot like the train that we talked earlier. This is 1 for on, 0 for off. The frequency that it's running at, which here they all just start at a default value, and then a key, which is again a lot like React keys. Then we have this idea of a next voice, and so what I'm going to do is when we update voice state, we get a Midi event. If the Midi event has a type property and the type is note on, then I'm going to allocate that next voice. I'm going to say like, the next voice in the array, set him to gate 1, give him a new frequency value, and then increment my pointer. So I'm going to kind of round robin through the voices array. If I get a note off, I'm going to go and find the voice that I had allocated for that frequency and put the gate back down to 0. Then jumping back down to the bottom of the file here, so we've updated our voice state, and then we want to map the voices over the synth voice function. So let's take a look at that. So synth voice will receive one of those, objects from the array above. It's got a gate, a key, and a frequency value. So the first thing I'm going to do is make a constant value. This thing just outputs whatever value you give it forever. So the value here will be 0.2 times the voice gate. The key, I'm not going to go into the key because I realize we're running up against time, but basically keys are your way of telling elementary, hey, this is a constant value node, and if you see the same constant value node on a subsequent render path with the same key, we're talking about the same thing, just change that one's value. Like you don't need to rip up, it would be like trying to rip up the DOM and rewrite it when you didn't really have to, right? Then we've got an ADSR, just like we talked about in the prior example. And here we're just multiplying the envelope, the ADSR, by a blep saw. And a blep saw is another built-in, it's like cycle in that it generates a tone at a given frequency, but here blep saw is a anti-alias sawtooth oscillator instead of a sine tone. So again, we get the Midi event, we change the state, we run that mapping function again, we hand it over to elementary to render. Elementary gets you from A to B with the minimal operations necessary, and then you're hearing us in. Good so far?
Once again, at a high level, yes. Blipsaw sounds like it might be a word you made up, and both of you are just holding a straight face. But
it's, I mean, you can go read about it if you want. It's a polyblep sawtooth oscillator. There's a lot of literature on it. Blepsaw is just the shorthand that I came up with for the library name.
Okay.
It's only going to be funny if he actually says these words we keep making up in his other conversations, Nick. You have to wait and see. Hopefully TJ didn't hear that.
Well, it's the one advantage of I think if you come in with audio background or if you really get into this, I imagine most of the guides and the tutorials you find online, your library is brand new. They're going to be in C++, or they're going to be talking about these other things. So you might be learning these stuff from some other technology. So at least until your thing takes off and gets super popular, right, there's going to be a translation people are going to have to do between when they find some deep dive on some audio concept and then figure out how to translate it into what you have here.
Yes. Yeah, I mean, I think that probably the beginner experience using elementary will be a lot of just developing understanding of what library functions are available and what they each do. And this is, I think, a common experience. I mean, I was a MaxMSP user. Do you guys know MaxMSP or Pure Data?
Yeah.
So these are other audio development tools, and they're more in the visual programming field. And you can put a blep saw and draw a line to your filter and whatnot. And I think that's just part of working with a tool like that is kind of developing an understanding and a familiarity with kind of the vocabulary that the tool works in. Because there's a million different concepts in audio, and I'm trying to represent a helpful like subset of building blocks. and if I get the subset right, then you can kind of do all sorts of stuff if you know the vocabulary of it.
Yeah, and I really like that it's starting like it's like the right level of like low level versus high level, because it's still relatively low level in that, I mean, it is, you're working at the node level, you're working with like a command line, but I think that like going into your future plans, I think that makes a lot possible in terms of there's a lot you could build on top of this, like the visual tools you said, like there's no reason that can't be built on top of this, throwing a UI on top of this. So there's a lot of potential.
So I want to show really quickly, because this was, going back to your earlier question about how do I put a knob in front of here. So I don't have an Electron app set up. I don't have a web server set up, but I have this console.log for when I push a note, right? And that's just coming in for any MIDI event. So if I turn some of these knobs on my controller here, you can see those flying through, right? And I could just take those events and pump their value wherever I want into my graph.
Yeah, so you could take a physical thing and have that be your it's funny because HTML knobs will take a little bit of work, but if it's like a physical keyboard, like that's totally doable easily.
And dude, like a keyboard like this Akai Mini is like it doesn't have a lot of keys, but you can change octaves. It also has pads you can map to things and these knobs. Yeah. Sometimes you just need to turn a dial to get something how you want it. And being able to connect this with JavaScript really kind of completes the circle in a lot of ways.
Yeah, I'm super excited about that. I mean, there's a whole part of this story about the user interface side of this, and there's a lot of work that I want to do to really make that a great experience. But it's funny, like personally working with this, I'm like so like at home kind of using my own hardware knobs and just wiring through that callback. It's just like it's just such a quick way to have tactile input for what you're doing.
Yeah, I'm not sure I've ever thought about a physical device as being a user interface, but I suppose it is. Like I immediately went to HTML and Nick goes, well, I have a user interface sitting over here and started messing with it. It's like
it definitely
pre-exists the web for sure.
Well, and you're more familiar with the target market of this than I would be, right? Because I might want my HTML buttons, but I'm also like, that's because I don't really know what I'm doing either. So
I don't either.
Well, Nick, this has been awesome. Is there anything we've missed? And if not, like you should give us like a link dump. Where's the best place to follow you, to follow the project, to get started? Let's get people what they need to know.
Yeah, totally. Let me see if I can throw it in the chat here.
If you throw it in the private chat in StreamYard, I can relay it.
Okay. So there is the project website, which is just elementary.audio. I would say start there. You can read all the documentation there. That is where you will learn about like the vocabulary of what's available in the library.
It's a fantastic domain name, by the way.
Thank you. Then there is, actually, if you go onto Elementary Audio, you'll see there's a link to a Discord community. This is just a kind of a spot where I am most active, most like, readily updating people on what's happening. If you're curious, have questions, anything, jump in there. I'm at Nick. You can hit me up. I check in every day. Happy to chat. And then I'm also going to point you to my blog, which is nickwritesablog.com. And I'm writing there kind of as I'm going through this. There's an introductory blog post kind of on the backstory of this project. There's a DSP tutorial on how I made a drum synth on this with this same project. And I got a lot more that I'll be sharing in the coming weeks.
It's funny because naming things is supposed to be one of the hard problems in computer science, but it seems like you've got that not just nailed. Your names are on point.
I don't know. Nick writes a blog. I still question that one sometimes.
I like it.
Appreciate it.
Well, cool. Let's see. To wrap up today, is there anything else we need to plug? Dan, do you need to plug anything?
I would mention the Enterprise React newsletter. That's one of the ways we hear about great people doing interesting things and then get them to come on the show. So if that's your kind of thing, like subscribe to it. It's by developers for developers.
And I dropped that in the chat. And my plug at the end here is I'm just going to remind you by pasting in one more time the React Wednesdays websites, just because you can subscribe to us. You can learn about upcoming episodes. You can hear from awesome people like Nick and learn some fun stuff of what's going on in the JavaScript and React worlds. So, but yeah, Nick, this was awesome, man. I learned. I'm still no audio expert, but when the audio bug hits me, I know where to go now, right? Like I'm a JavaScript person, and it feels somewhat achievable.
That is really great to hear. That is exactly one of the things that I want to. I don't know. I want people to feel that way. I want it to feel accessible.
Well, awesome. Well, best of luck with the project, but I think you have something pretty awesome going on. And yeah, that's it for this week. So reminder, everybody, we do this every Wednesday, and until next week.
Thank you, guys. It's
Nice
been a real
meeting you,
pleasure.
Nick.
Yep.
Have a good one.
You too.